Yeah, good morning. This is Dr. Subramanya Rao, Professor, EC Department, Sasi Institute of Technology and Engineering. In the Signals and Systems subject, in the last class, we have started the classification of signals, and we have seen the first three classifications of signals. And in this class, I am going to deal the remaining three classifications of signals. So today let us start with energy and power. So first let us define in continuous time, later in discrete time. A signal is said to be an energy signal. If you want to define energy, so to define energy or power, we need to define two parameters. Those are total energy E, and the average power P. For every given signal, first we need to define these two, either in continuous time or discrete time. Based on the values of this, we are going to define whether the given signal is energy signal or power signal. So once if these two are defined, a signal is said to be an energy signal if the total energy E is finite. If the total energy E is finite, we can say that the signal is an energy signal. It means we can show it as 0 less than E less than infinity. For this type of energy signal, we need to calculate the average power also. So average power for this type of signal will be 0. So average power for this type of signal P will be 0. So broadly we can say that a signal is said to be an energy signal if the total energy E is finite and the average power P is 0. Similarly, we can define the power signal. We can apply the same concept here also. A signal is said to be a power signal if the average power P is finite. It means if the average power P is finite, it means if 0 less than P less than infinity. Finite means it is shown like this, less than infinity. We can say that the given signal is a power signal. So for a power signal, if you calculate the total energy E, it will be infinity. E will be infinity. So a signal is said to be a power signal if the average power P is finite and if the total energy E is infinity. So these are the definitions of energy and power. We can see it for continuous time and discrete time. First let us see the parameters for continuous time. In case of continuous time, the total energy E is integral minus infinity to infinity magnitude of x of t square dt. This is the formula for total energy E. So we are calculating square of the magnitude of the signal, area under, integration means area under square of the magnitude of the signal will give energy. Similarly, average power P. What is the idea of average power? Calculating the energy in a specific interval, let us take minus t to t divided by the duration 2t. That is the idea. So that's why P equal to limit t tends to infinity 1 by 2t. We are calculating the integral for specific period minus t to t magnitude of x of t square dt. If we observe, this is the average power because we are calculating the energy square of the magnitude of the signal in specific interval of minus t to t. It means in a duration of 2t, we are calculating the energy divided by the duration 2t. Later, if we make t tends to infinity, we get the average power. So these are the two parameters in continuous time. For every given signal, we need to check these two formulas for checking whether the given signal is energy signal or power signal. Okay, next. Next, let us define the same thing for discrete time also. Here also the definition of energy signal and power signal are same. Energy signal and power signal are same, where the energy E is finite and P is 0 for a signal to be an energy signal. And similarly for power also, power signal, we can apply the same definition, that is P should be finite, then we can confirm that it is a power signal. For the same signal, if you calculate E, total energy E, it will be infinity. Same, but the notation will be changed. Let us see the formula for total energy E. Total energy E in discrete time. Earlier we have taken integration, now it is a summation because it is discrete time. So E equal to summation of n equal to minus infinity to infinity, sum of the squares of the magnitude of the signal. So that is the total energy. Here we are adding square of the magnitude of the signal, given signal are added from minus infinity to infinity, then we get the total energy. Similarly, average power. Average power. We can apply the same concept what we have applied for continuous time. We are going to calculate the energy in specific interval divided by that interval. So it is nothing but limit n tends to infinity 1 by 2n plus 1 summation of small n equal to minus n to plus n magnitude of x of n square. Try to observe the difference between this average power and continuous in continuous case. If we observe, it may be confused why we have taken 2n plus 1. Because the range from minus n to plus n, we have 2n plus 1 number of samples. So we calculated the energy of the given signal, square of the magnitude of the sum of the signals in the specific interval minus n to plus n divided by the duration 2n plus 1, because there are 2n plus 1 number of samples between minus n to plus n. So by using these two formulas, we can tell whether the given discrete time signal is energy signal or power signal. Okay. Yeah, now let us do some problems. First, in continuous time, this is a given signal, x of t equal to e power minus phi t into u of t. So whatever may be the signal, immediately we need to apply, we need to calculate E and P, total energy E and average power P, we need to calculate. Directly I am doing it as we know the formula, integral minus infinity to infinity, magnitude of x of t square dt. If you apply it, integral, because of u of t, the limits of integration change it to 0 to infinity. X of t, e power minus phi t whole square. Magnitude of e power minus phi t is e power minus phi t only. So e power minus phi t whole square. It will become e power minus 10t dt. Now if you find the integration, it is e power minus 10t divided by minus 10. Apply the limits 0 to infinity. It will give 1 by 10. You can calculate it 1 by 10. Okay, this is energy. So 1 by 10 joules. Okay, so as the total energy E is finite, 1 by 10 is a finite number, here itself we can say that the given signal is an energy signal. But we need to calculate average power for this also. We need to check whether we get 0 or not. So calculate the average power P. What is the formula? Limit t tends to infinity 1 by 2t integral minus t to plus t. Directly I am putting it e power minus phi t magnitude whole square, that is e power minus 10t u of t. U of t. So we can solve it in the similar way. limit t tends to infinity 1 by 2t, we get something. We get something if we solve it. So here the idea is, because of the answer obtained for this integration, if there is a chance of cancellation of t here, then only we get a finite answer. Here if you observe the integration of it, e power minus 10t divided by minus 10, apply minus t and plus t limits, then we get some answer. That answer, with that answer, there is no chance for the cancellation of this t. Then immediately if I substitute t tends to infinity, answer will be 0. I hope you understood. You need not calculate. Even if you calculate, there is no scope of cancellation of this capital T. So that's why if I apply limit t tends to infinity here, it will be infinity, 1 by infinity will be 0. Okay. So that's about the first problem. Let us see another problem where here it is an exponential signal. Here also we can apply E equal to integral minus infinity to infinity magnitude of e power j 3t plus pi by 2 square. Here it is very simple. Magnitude of e power j theta equal to 1. That is a known thing. So here you can easily calculate integral minus infinity to infinity 1 dt or 1 square dt, that is equal to infinity. Integral minus infinity to infinity of 1, you get the limits. If you calculate, we get infinity. So the total energy is infinity for it. If you go for average power P, limit t tends to infinity 1 by 2t, let me put the direct step, minus t to t, magnitude of it is 1 dt. 1 dt. I put a direct step, 1 square, it will become 1. And integration of 1 is t. If we substitute the limits, it will be t minus of minus t 2t. So it will be limit t tends to infinity 1 by 2t. Here the integration answer is 2t. So here if you observe, similar to the previous problem, the answer obtained from this integration is now possible to cancel the t here. There is a scope now to cancel this t with the answer obtained. So we will have a finite answer. So directly you can take p equal to 1. So here the average power is finite and total energy is infinity. So here the given x of t is a power signal. Power signal. Here also you can confirm. I forgot to confirm. Here the given x of t is energy signal. Here also you can confirm that it is a power signal. Like this we can easily find out whether the given continuous time signal is energy or power. Similarly you can do the same for discrete time signals. Yeah, similarly let us take two discrete time signals. Here also the procedure is same, only the formula's notation is changed. Now it is in discrete time. So the given signal is 1 by 3 whole power 9 to u of n. Directly you can calculate the total energy E in discrete time. The formula is n equal to minus infinity to infinity magnitude of x of n square. It means 1 by 3 whole power n square. So directly we can do this, 1 by 3 whole power 2n, you can send it inside, it will be 1 by 9 whole power n. Because of u of n, the summation limits are changed to 0 to infinity. Because u of n will be 0 for n less than 0. So that's why the limits are changed to 0 to infinity, it will be 1 by 9 whole power n. In mathematics, we have two formulas, infinite series formula and finite series formula. Now, it comes under infinite series formula. If you remember, summation of n equal to 0 to infinity a power n will be confined to 1 by 1 minus a, provided magnitude of a should be less than 1. This is called infinite series formula. Infinite series formula. Similarly, we have one more finite series formula. We will see it in the next. So 1 by a power n. So this can be simplified as 1 by 1 minus 9. 1 by 1 minus 1 by 9. This is equal to, I think, 9 by 8. 9 by 8. So here itself, the total energy E is finite. Here itself we can confirm that the given signal is an energy signal. But we need to find out P also. If you find out the average power P, limit n tends to infinity 1 by 2n plus 1. Let me use the direct answer. N equal to minus n2 plus n of, I'm putting directly 1 by 9 whole power n. Now, because of u of n, the limits are changed to because of u of n, the limits are changed to 0 to plus n, 1 by 9 whole power n. Now, it is called finite series formula. In mathematics, we have also finite series formula. Suppose 0 to n or 0 to n minus 1. Let us take 0 to n only. 0 to n a power n. Here the length of the signal is n plus 1, 0 to n. So n plus 1 length means it is a finite duration signal. That's why it is confined to 1 minus a power n plus 1 divided by 1 minus a, provided mod a less than 1. This is called finite series formula. Okay, based on this, we can apply it. Limit n tends to infinity 1 by 2n plus 1 into 1 minus 1 by 9 whole power n plus 1 divided by 1 minus 1 by 9. Here the idea is, whatever may be the simplification of this signal, it is very clear this simplification of the signal is no way cancelled 2n plus 1. Okay, so with this answer, there is no chance for this n to cancel. So ultimately, if n tends to infinity is applied, we will get 0. That's the idea. You need not simplify it further, because the simplification of the term in the bracket will not cancel this n. As long as n is not cancelled here, if I substitute n tends to infinity, entire term will be 0. So that's why P is 0. So total energy E is finite and average power P is 0. So the given signal X of n is energy signal. Energy signal. Okay, this is one type of signal. Here also, the same type of signal what we have taken in continuous time, I have given here for easy understanding, for easy correlation of continuous time and discrete time. Here also, you can easily map it. Total energy E, summation of n equal to minus infinity to infinity, magnitude of e power j pi by 2n plus pi by 4 whole square. Fortunately, the magnitude of e power j theta equal to 1. 1 square is 1. So, summation for minus infinity to infinity of 1 will be infinity. So, the total energy E is infinity. Similarly, you can find out the P. Limit n tends to infinity 1 by 2n plus 1. Summation of n equal to minus capital N to plus capital N of, directly I am putting 1. So here also minus n2 plus n, minus n2 plus n, we get 2n plus 1. So minus n2 plus 1 of 1. How many 1s are there? 2n plus 1s are there. Limit n tends to infinity, 1 by 2n plus 1 into, the answer is 2n plus 1. Here there is a scope of cancellation of n with the answer obtained from the summation. So now these two are cancelled out, so the answer is 1. So here the average power P is finite and the total energy E is infinity. So we can say that the given signal X of n is power signal. Like this, you can do n number of problems to find out whether the given signal is energy signal or power signal. Thank you.